Welcome to today's explainer. If you've ever walked through an old growth forest, you've probably noticed something absolutely incredible. There is literally zero waste. Every single fallen leaf, every decayed branch, well, it just becomes an essential nutrient for the next generation of life. Human industry historically hasn't been quite as elegant, so today we're going to look at a revolutionary concept that aims to change all that by mimicking natural ecosystems to completely transform industrial manufacturing. Here is our roadmap for today's session. We'll be covering 1. Rethinking industrial systems, 2. The advantages of ecology, 3. Industrial symbiosis explained, 4. The Kalundborg case study, 5. Benefits of symbiosis, and finally, 6. Real-world limitations. Let's get right into it.
Okay, let's dive into this. Section 1. Rethinking industrial systems.
For centuries, our industrial complex has operated on a pretty flawed premise: take, make, and dispose. We extract raw materials, we build our products, and whatever is left over just gets dumped. It's incredibly inefficient, and it creates a massive waste problem. To solve this, academics and engineers develop something called industrial ecology. It's often referred to as the science of sustainability. At its core, it's the careful study of the flow of materials and energy in our industrial and consumer activities. The ultimate goal? To entirely reorganize the industrial system so that it works exactly like a natural ecosystem, drastically reducing our environmental impact and material wastage.
You can really see the stark contrast between our old methods and this new vision. Traditional linear systems essentially draw a straight line, right from resource extraction straight to the landfill. An ecological system, on the other hand, bends that line into a closed loop. The fundamental philosophy here is absolutely crucial. The waste of one industrial process must become the vital food or raw material for another.
Moving on to Section 2, the advantages of ecology. So why do this? Well, transitioning to an ecological mindset actually makes hard operational sense across 3 main pillars. Economically, it helps facilities realize significant cost savings and even generate income by selling byproducts instead of paying to throw them away. Environmentally, it minimizes ecological impact, which helps companies improve their performance and actually become more competitive. And societally, it helps communities maintain a really sound industrial infrastructure without sacrificing the quality of their local environment. Plus, it gives government agencies a fantastic framework to design smarter environmental policies.
Which brings us to Section 3, Industrial Symbiosis Explained. To make this broad theory a reality, we use a very specific operational strategy. Industrial symbiosis is a highly effective subset of industrial ecology. So while industrial ecology is the broad science and study of these systems, symbiosis is the actual physical exchange happening on the ground. It's the trading of materials, energy, water, or byproducts among different industrial or business units. Think about the biological definition of symbiosis: organisms living together for mutual benefit. Well, here, it's factories doing exactly the same thing.
But, it's not just about running a wastewater pipe from one building to the next. Industrial symbiosis also includes the shared use of assets, shared logistics, and shared expertise. By grouping together in these eco-industrial parks or networks, these businesses pool their resources to add immense value and reduce costs across the board. They literally survive and thrive together.
Now, let's look at a real-world example in Section 4, the Kalundborg case study.
And this brilliantly illustrates what we're talking about. Does this actually work in the chaotic real world of heavy industry? To answer that, we look to the gold standard, Denmark's Kalundborg Industrial Park. Now, at first glance, this flow diagram looks incredibly complex. Kind of like a messy wiring diagram, right? But don't be overwhelmed. What you're really looking at is an incredibly elegant web of relationships where absolutely nothing goes to waste. Let's deconstruct this and trace just one specific pathway through this industrial ecosystem. Step 1. The Asnæs coal-fired power plant generates electricity, and in doing so, it produces a massive amount of processed steam. Now, instead of just venting that into the atmosphere, Step 2 happens. That steam is piped directly over to Novo Nordisk, a pharmaceutical plant, which desperately needs that precise heat for its operations. Then, Step 3, Novo Nordisk's biological processes generate a byproduct, this yeast slurry. Rather than paying to dispose of it, they send that nutrient-rich liquid sludge directly to local pig farms to be used as feed and fertilizer. So energy becomes manufacturing heat, which then becomes agricultural food.
Let's see how this builds with a second pathway. We'll begin with the Status Oil Refinery. Step 1, it produces clean gas, which it sends over to the Asness power plant to use as fuel. Step 2, in return, Asness sends cooling and purified water right back to the refinery. It's a highly efficient, multi-directional exchange of energy and resources. And it doesn't even stop there. Step 3, the Status Oil Refinery extracts sulfur from its cleaned gas. That sulfur is then sent straight to the Chimera plant, which requires sulfur as its primary raw material to produce sulfuric acid. The waste of the oil refinery literally builds the product of the chemical plant.
Let's talk about the big picture payoff in Section 5, Benefits of Symbiosis. Seeing the Kalundborg math really drives the point home, doesn't it? By linking together, these companies optimize the use of material and energy at efficiencies that are, frankly, mathematically impossible to achieve by any single process alone. The advantages are crystal clear. You drastically reduce your raw material costs, and you completely slash your waste disposal costs. You open up totally new business opportunities, earning revenue from things you used to just throw in a landfill. And because fewer waste go to landfills or incinerators, you heavily reduce your carbon emissions, which absolutely skyrockets the green image of the company. It's a win for the balance sheet and a massive win for the planet. But we have to be realistic. Section 6, Real-World Limitations. Now, you might be wondering, if this is so amazing, why isn't every single industrial park operating like Kalundborg? Well, the real-world friction is pretty significant. First off, this concept often gets a very low priority in traditional boardrooms that are laser-focused on immediate profits. Second, there's the incredibly high cost associated with physical relocation. Facilities actually have to be physically close to each other to share things like steam or water efficiently. Furthermore, there's often a lack of initial government support and a genuine reluctance from industries to invest in the unproven technology required to link these systems safely. And finally, there are some really complex legal implications. Think about it. If one factory relies entirely on another's waste to operate, who is legally liable if the supplier shuts down for a week? What you should really take away from all this is that while the hurdles are definitely real, the potential is absolutely massive. We are looking at a fundamental shift in how human beings manufacture everything from electricity to medicine. It challenges us to stop seeing waste as a dead end and actually start seeing it as the beginning of a brand new cycle. It leaves us with a fascinating, provocative thought. If we can overcome the logistical and legal hurdles, will the factories of tomorrow be built like forests? Thank you so much for joining me for this explainer, and keep questioning how the world around you is built.